Good morning dear cadets. So we are in the actinoids. So yesterday I taught you the electronic configuration of actinoids, and there is some controversy regarding the electronic configuration of thorium and 1-2 more members. So I hope that both version I have included, so you will not have any problem. Okay, so now we are moving toward the physical trends of actinoids. Okay, now once the electronic configuration is completed, the first and foremost thing is evaluation of their oxidation state, because oxidation state depends upon electronic configuration only. Not only oxidation state, there are so many things which are depends on electronic configuration only, but the first and foremost thing is the oxidation state. So just see, +3 is the most stable oxidation state. Okay, for actinides, where we are actinides oxidation state, actinoids. Okay, so just see, +3 was the most stable oxidation state for the lanthanides also and for actinides also. Okay, now see the differences between lanthanides and actinides. In addition to the +3, they exhibit +4, +5, +6, +7 oxidation state also. Okay, now in case of lanthanide, what was there? +3, +2, +4. Here what is there? +3, +4, +5, +6, +7. Means the wide range of oxidation state actinides are showing. Okay, the most of the actinides are radioactive, but very less lanthanides are radioactive. This is also the difference. Almost many elements of the actinides are radioactive, but in case of lanthanides, very less number belongs to the radioactive compounds or elements. Okay, from plutonium, now plutonium is one of the member of actinides. From plutonium and means actinoids exhibit very less range of oxidation state, because they are heading towards stable electronic configuration. Here write stable electronic configuration. They are heading towards the stable electronic configuration. Am I correct or not? So try to understand, plutonium onwards, they will not exhibit such wide range of oxidation state. Now there is one question. The first question is this one only. Lanthanides is not exhibiting the variable oxidation state. Their range of oxidation state is limited, while actinoids, they are exhibiting the wide range of oxidation state. Okay, so the first question is, actinoids exhibit variable oxidation state unlike lanthanides. Our second question is, the range of oxidation state of actinides are wider than lanthanides. Why? So just see, Ln means lanthanide, An means actinoids. So just see, what is the general electronic, what are the subcells which are present in the electronic configuration of lanthanides? 4F, 5D, 6S. An, actinides, 5F, 6D, 7S. Okay, now study only in their distance from the nucleus. I have shown you that diagram is very important. On the basis of that, you can explain so many properties of lanthanides and actinides. So in case of lanthanides, the energy difference between 4F, 5D, 6S subcell are large. Okay, in very simple answer is there. Just see, the limited range of oxidation state of lanthanide is because of the more energy difference between 4F, 5D, 6S. So if energy difference is more, then what would be there? Now those electrons which are present in those subcells will not take part in the chemical reaction or bond formation. So they will exhibit the limited range of oxidation state. While in case of actinoids, what is there? Actinoids, the involved subcells are 5F, 6D, 7S. These are actinoids. 5F, 6D, 7S. So just see, the energy difference is very limited. Energy difference between these subcells are limited. So the electrons which are present in these subcells Electrons which are present in these subcells, they will take part in the bond formation because energy difference is less. So by supplying limited amount of energy, all electron will come out and all will take part. So they will exhibit the wide range of oxidation state. So just see, in case of lanthanide, the energy difference between 4f, 5d, 6s subcell are large. Hence their electrons do not take part in bond formation. Hence range of oxidation state is limited. +2, +3, +4. +2, +3, +4. Now change the paragraph. In case of actinides, the energy difference between, after this one I wrote this side, okay, space is not there. In case of actinide, the energy difference between 5f, 6d, 7s are very less. Hence their electrons take part in bond formation or chemical reaction. Hence they exhibit wide range of oxidation state, that is +2, +4, +5, +6, +7. +2, +4, +5, +6, +7. In addition to the +3, you can mention here. Write down this one +3. Okay, +3, +4, +5, +7. Okay, so the wide range of oxidation state is because of this reason. Okay, but just remember this one, their most stable oxidation state is +3 only. Let it be lanthanide or actinides, their most stable oxidation state is +3 only. Okay. So next trends in ionization enthalpy. So ionization enthalpy of actinides are more than that of lanthanides. Okay. Now already I explained you the reason. Ionization enthalpy of actinides are more than that of lanthanide. Okay. Now this question is wrong. Just see. The ionization enthalpy of actinides are less than that of lanthanides. Just see the answer. The subcell of lanthanides, what are the subcells of lanthanide? 4f, 5d, 6s are more penetrated toward the nucleus. Hence for removing their electron, more energy is required. Hence ionization enthalpy is more. Okay. Whose ionization enthalpy? Ionization enthalpy is more for lanthanide. Okay. Any problem? Penetration means getting near to the nucleus. Penetration means getting near to the nucleus. And who is getting near to the nucleus? Subcells. Now in case of actinides, what are the subcells? 5f, 6d, 7s are less penetrated toward the nucleus. When yesterday I made you the distance from the nucleus of different subcells. So you might have seen that 5f, 6d, 7s, they are away as compared to the 4f, 5d and 6s. That diagram just you refer to understand all these things. So just see. So actinide subcells are less penetrated toward the nucleus. Hence for removal of electron, less amount of energy is required. Hence their ionization enthalpy is less. Bracket here write actinides. Now try to understand. We can ask similar question. Just see. Actinides are, now I am asking this question. Actinoids are more reactive than lanthanoids. Why? Just see here. What is the answer here? Answer is ionization enthalpy of actinoids is less. Ionization enthalpy of actinoids is less. Now why it is less? Answer is here. Okay. So here things are interlinked. Actinides are more reactive because their ionization enthalpy is less. Why their ionization enthalpy is less? Their ionization enthalpy is less because their outermost subcells electrons, they are less penetrated toward the nucleus. Hence, by giving small amount of energy, those electrons can be removed. Okay. Now, so ionization enthalpy matter is over. Now, next one is actinoids contraction. Actinoids contraction. So, just like lanthanide contraction, actinide contraction is also there. Only the difference is there in case of lanthanide contraction is there because of the poor shielding effect of 4f orbital or 4f subcell. Here actinide contraction is there because of the poor shielding effect of 5f subcell. Okay, and definition is same. With the increase of atomic number, there is a decrease in the atomic size. There is a decrease in the atomic size of actinoids member. So, decrease in the atomic size with increase in atomic number, this is known as actinoids in case of actinoid series. Okay. Now, reason I wrote here, explanation of actinoids contraction. So, actinoids contraction is due to poor shielding effect of 5f orbital resulting into attraction of electron towards the nucleus, element to element. Okay, that much explanation is enough. Okay, so shielding effect of 5f subcell is less, so nuclear charge will cross the 5f orbital, it will reach to the outermost cells electron. Now they will be attracted toward the nucleus. Element to element, why I am writing? Because at a time only electron will not be filled in the 5f orbital. Element to element, in successive element one electron keep increasing in the 5f orbital. So what is there? With the increase of each electron to electron, the shielding effect is poor here. Okay. So, resulting overall decrease is known as actinide contraction. So, there is no much difference between lanthanide contraction and actinide contraction. But now, which question I am asking, that question is important. Just see. Of course, in lanthanide contraction is there. In actinoids contraction is there. But it is proved that element to element, the lanthanide contraction is less as compared to actinoid contraction. Why? Are you getting my point or not? Means element to element, just see. What is the first member of lanthanide? Okay, cerium. What is the second member? Promethium. Okay. Now in case of actinoids, which is the first member? Thorium. Then which is the protoactinium, that is the second member. Now try to understand. Means decrease in, just understand this one properly. Decrease in, this is cerium to Ce2 PT. Just a minute. Let me check their symbol. The symbol is PR. Okay. PR. Okay. This is lanthanide. Now here what is there? Thorium and Pa, protoactinium. So my question is element to element. You can take third member here. You can take here third member. Third member is here neptunium. Here cerium, promethium, neodymium. Next member is neodymium. Yes, Nd. So just see, what is my question? Try to understand. My question is, as you move thorium to protoactinium or protoactinium to neptunium, similarly as you move cerium to promethium and promethium to neodymium, here these are the members of lanthanide. Here element to element, lanthanide contraction is less. What is this one? Lanthanide contraction is less. In case of this one, thorium to protoactinium or protoactinium to neptunium, actinoid contraction is more element to element. So why? Element to element, actinoid contraction is more than that of lanthanide contraction. Why? This is the question. I can hope that you have got the meaning of this one. You have got the meaning of this one. I am deleting because already I wrote the answer for this question. Okay. So element to my purpose is to understand first element to element. What is the meaning of element to element? Means moving from one element to another element. So when we move one element to another element in case of lanthanides, so contraction is less, while in case of actinides, as we move from element to element, then what is there? Contraction is more. Okay, so obvious answer is there. Now why here in lanthanide contraction is less? Because as compared to 5F, 4F shielding effect is strong. So when 4F shielding effect is strong, so the nuclear charge will not reach to the electrons of 4F. Then what is there? They will not be attracted toward the nucleus. Since the shielding effect of 5F subcell is poor, so the nuclear charge will reach to the electron or different electrons of 5F and it will attract. Now I am hoping that you have not got, but you will understand, don't worry. So dear cadets, just see two very important questions, and almost in alternative years these questions have been asked in the 12th class board exam. Just see, the first question is actinoid contraction is more in element to element as compared to lanthanides. Or same question can be asked like that also. Lanthanides contraction is less for element to element as compared to actinides. Here also write for. Okay. Now try to understand. I hope that you have got what is the meaning of element to element. Means as we move from one element to another element. Okay. Now earlier only I explained you. Now just see, the explanation of this question is here. Just try to understand. Don't consider this one. This is the part of this question. Okay. Just see. This is the order of shielding effect. 4F, 5F, 6F, 7F. Means what is there? We require here 2F orbital. 4F and 5F. 4F for lanthanide, 5F for actinides. So the shielding effect of 4F is better than 5F. Okay. That only reflect by seeing this order. So what is the meaning of strong shielding effect? The meaning of strong shielding effect is nuclear charge will be checked properly by the inner cells. Now here 4F subcell. Okay. Now poor shielding effect means nuclear charge will not be screened or checked by inner cells. Here inner cells is 5F. Okay, in case of actinides. Okay, so when nuclear charge will reach to the outermost cell's electron, then what would be there? What would be there? It will be attracted towards the nucleus. Okay, now just see. What is our question? Lanthanide contraction is less for element to element as compared to actinides, or actinide contraction is more for element to element as compared to lanthanides. Why? Just see here. Very simple answer is there. Try to understand. In case of lanthanides and actinides, electrons are successively filled in 4F or 5F. 4F in case of lanthanide, 5F in case of actinides. Now just try to understand. Here I am explaining here only. Just see. Very simple answer is there. Now this is 4F. Okay. Now here 1, then 2, then 3, then 4, then 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. These are the electrons of 4F. Okay. Now try to understand. 4F shielding effect is strong. Here what is there? Nucleus is there. Now try to understand. 4F shielding effect is strong. So when nuclear charge will go here in 4F subcell, so it will check there only. So the electron which are successively filled element to element in 4F orbital, So nuclear charge is sealed here only. So electron which are successively filled, they will not feel attraction towards the nucleus. They will not feel attraction towards the nucleus. Then what would be there? They will not be attracted towards the nucleus. So what is there? Lanthanide contraction will be less or not? Will be less. Now suppose this is in case of 4F, this is strong. This is strong. What strong? What strong? Shielding effect. Now suppose this is 5F. What is this one? 5F. So what is their shielding effect? Their shielding effect is poor. So what is the meaning of poor shielding effect? Now when the electrons are filled in the successive elements, so what is there? This 5F orbital will allow the nuclear charge to go to these electrons which are successively filled in the 5F subcell. Then what would be there? Now they will be attracted towards the nucleus very much. So the actinide contraction is more or not as compared to lanthanide contraction, element to element. This is the reason. I hope that you have got. I wrote here. Just see. In case of lanthanide, the 4F subcell will shield electrons of 4F. Electrons of 4F strongly from the nuclear charge. Hence it is less for element to element. Okay. In case of actinides, the 5F subcell will shield electrons poorly from nuclear charge. Hence in successive element, incoming electron will feel more attraction towards the nucleus. Hence it is more. I hope that you have got this one. There is one more question. The chemistry of actinoid is complex, whereas the chemistry of lanthanide is simple or smooth. Why? Just see. What is the meaning of chemistry? Chemistry is somewhat related with the chemical compound. If wide range of chemical compound is there, then you have to study all the properties of different compounds. Then the chemistry become complex. If only 1-2 elements are there, or 1-2 compounds are there, very easily you can study their chemical properties. Very easily you can study or not. So the chemistry become smooth. Okay. In case of actinoid, what is there? They exhibit the wide range of oxidation state. Actinoids exhibit the wide range of oxidation state. So since their oxidation state is having wide range, so their chemical compound will also be more only, na? More the oxidation state, more will be the chemical compound. Hence study of their property is also required. That is why actinoids compound chemistry is complex. Now in case of lanthanoids, the range of oxidation state is limited. The range of oxidation state is limited. So what is their less number of chemical compound will form and their study will be easy. Now sometimes they ask such type of question also. The chemistry of lanthanide is identical, or the chemical property of lanthanides are identical, while the chemistry of actinoid is not identical. Okay. Now such type of question will also be asked. So try to understand. Identical means chemistry means different properties is almost identical in case of actinides, but same is not the case with the actinoids. Lanthanides chemical properties are almost, our chemistry is identical. Identical means similar. So try to understand who is responsible for different chemical property. Electron. Now in case of lanthanides, their valence shell electrons are deeply penetrated toward the nucleus. So they are not affecting their chemical property, while in case of actinides, their electrons are less penetrated toward the nucleus. They are present in periphery. So those electrons can affect their chemical properties. Okay. Lanthanide electrons are not free to take part in the chemical reaction, but actinides electron, they are outside, they are free. So that is why the chemistry of lanthanides is identical. Now such type of questions are also there in the different books, but basically this is the question. The chemistry of actinide is complex, while the chemistry of lanthanide is simple. So actinide form different compounds due to wide range of oxidation state. Hence range of compound is more, while in case of lanthanides range of compound is less due to less number of oxidation state. That is why the chemistry of actinoids is complex. So in this way these two questions are also completely completed. Now what are the similarities and differences of lanthanides and actinides? So dear cadets, now almost we are in the last leg of this unit. Okay, the first point note down, promethium is the only radioactive element present in the lanthanide series. So in actinides almost all are radioactive, but in lanthanides there is only one element, that is promethium, Pr. Okay, now there are some questions. What are transuranium elements? Elements after uranium in actinoid series is called transuranium element. So uranium is 92, after 92 what are the elements? Neptunium 93, plutonium 94, americium 95, curium 96, etc. They are transuranium elements. Next question is, why do lanthanides and actinides form complex compound? For the formation of complex compound in transition elements I taught you. There are certain conditions. Number one, atomic and ionic size should be small. There should be availability of d or f orbital, vacant d and f orbital, and high nuclear charge. Okay, so just see, actinides and lanthanides both form complex compound. Why? Due to small atomic and ionic size? Yes, they form. Next one is their nuclear charge, high nuclear charge. If size is small, nuclear charge will be more, and availability of vacant f orbital. So vacant f orbital is there. When it will be vacant f orbital? Basically in tri-positive oxidation state. Tri-positive, or it doesn't mean that entire f orbital should be vacant. Even 1, 2 orbital out of 7 orbital, if 1 or 2 are vacant, then also they will form the complex compound. There is one question here. Tendency to form complex compound is more in actinoids than lanthanides. Why? Just see. Just now I have finished. Actinoid contraction is more than that of lanthanide contraction. Okay. So the one of the important condition for the formation of complex compound is atomic and ionic size. So whose atomic and ionic size will be small? Actinides. Atomic and ionic size will be small. So actinides atomic and ionic size is small, hence their tendency to form complex compound will be more due to more lanthanide contraction. So due to small size of actinide, due to more actinide contraction, their tendency to form complex compound is more. One more question is there. Why do lanthanides and actinides form colored compound? Why? Okay. So for the formation of colored compound, what is the essential criterion? There must be unpaired electron in f orbital. Second one is f orbital is splitting, just like d orbital is splitting, T2G and EG set. And third one thing is, just like DD transition, FF transition should be there. FF transition. Okay. So now the last part of this unit is similarity and differences between lanthanides and actinides. So their answer I will not write. Now while explaining the F block elements, many places I told. All those knowledge you have to sum up. Then your differences and similarities will be over. Now I will explain that one. What are the similarities? The first similarity is both are the F block element. What is the second similarity? F orbital is progressively filled. Progressively filled. Both form complex compound. Both form complex compound. Both are paramagnetic. Many places they are paramagnetic or not. Now what are the other similarity? Other similarity is both are getting contracted due to lanthanide contraction and actinide contraction. And what is the other one? So just see, nitrate, sulfate and perchlorate of lanthanide and actinides, they are soluble in water, while hydroxide, fluorides and carbonates of lanthanide and actinides, they are insoluble in water. So these are the similarities. What are the differences? The first difference is this one only. In lanthanides only promethium is radioactive, while in actinides all are radioactive only. What is the second difference? The second difference is the magnitude of actinide contraction is more than that of lanthanide contraction. What is the another one difference? The chemistry of lanthanide is smooth, while the chemistry of actinide is complex. Now the most stable in similarity please add one more thing. Both cases their most stable oxidation state is +3. Okay, in similarity you should add. Now in differences, again come back to the differences only. In differences, what is there? Lanthanide exhibit the limited range of oxidation state. Their most stable oxidation state is +3. In addition to that one, they will exhibit +2 and +4. What about actinides? The range of oxidation state is more. What is there? In addition to the +3, what is there? +4, +5, +6 and +7. What else they are forming? Now tendency to form complex compound in lanthanide is less, while the tendency to form complex compound in actinide is more. So these are the some differences. There is one more thing is there. Actinoids form oxo ions. So now in the transition series only I told you what is the meaning of oxo ions. Just see, basically this is oxocation. Uranium oxide positive, uranium oxide tripositive, like that. These are oxo ions. Same thing is not possible in case of lanthanide. Lanthanide is not forming the oxo ions. In this way your this one D and F lock elements is completely completed. Okay, now tomorrow onwards I will start the coordination chemistry. Okay, the much awaited unit. Now whatever doubt you have got in this unit, definitely everything will be cleared in that unit, especially in case of splitting of d orbital and some other aspects, ligands and all those things. So I hope that you are getting this one. From my side I am doing my bit. Please you also cooperate with me, but I have not left any stone unturned. I have tried my level best and hoping that you will also do the same. Okay, thank you. Keep noting. If you will keep noting the things, then only you can revise afterwards. Okay, if you will not note down the things, you will forget after some time. Okay, and please compare the most important thing about the teacher is communication skill. Whatever I am teaching is directly penetrate to your brain. Okay, you can go through other website, other speakers, teacher, but just try to understand, see the quality of answers. It should be comprehensible to all. Okay, that is the meaning. So please just check the answers. Okay, thank you.